All right, everyone. So, in today's class, we are going to actually learn about chemical naming and formula writing, and as we discussing actually in our previous classes, if anybody can remember, we actually talk about the periodic table, and we also talk about the atoms, right? We will learn about the subatomic particles, which were like protons, electrons, and neutrons. And now we are actually, at the time when we are going to be start reacting them. Okay. And so at the end of this lesson, when we finish, you will be actually write the formulas for ionic and covalent compounds with given names. And also you will be writing, the names if you are giving the formulas, right? So you should be able to do these two things at the end of this lesson, hopefully. And before we start our lesson, though, I just want to actually ask you a question about like think about like what are the some household chemicals that you can think of, right? In your house or in your kitchen area, right? Let's think about it, and maybe you can just name me a couple of them that comes to your mind.
Um, Maybe like chloride and some cleaning products.
Right? Cleaning products, those are everybody has them. And I just
Yeah.
pick actually salt, right? Salt is actually another one.
hmm
We actually consume salt all the time. And does anybody know what the salt is made out of?
Um, was it sulfate?
Yeah, right. So it's actually made out of sodium
Oh,
and chlorine, right?
okay.
Okay, so as you can imagine, now we have two chemicals, right? Two elements. One of them is sodium and one of them is chlorine. And then when they actually react with them, and then we have a new compound, right? So now, how are we going to call it, right? So that's going to be a very important question in chemistry, right? Because if we don't know how to name it, then we're going to have a problem, right? So we have to really learn, how we're going to be calling them. And so that's exactly what we're going to be doing in this lecture. So let's go to our whiteboard. And so when it comes to naming a compound, we're going to be actually dividing in two sections. And the first one is going to be actually, let me just write it down here, metal or non-metal. Let's just start from the non-metal. Non-metal to non-metal compounds. Okay. And if we can actually refresh our memories, right? This is our periodic table. We've been seeing this for a while now. And if I ask you which elements are going to be like metal and non-metal, and this is my metalloid stairways, the red stairways is the metalloid stairways. So if I ask you if you're on the right side of this stairways, are you going to be metal or non-metal?
Gonna be metal.
You're going to be actually non-metal, right? Because again, if you are on the right side, you're going to be non-metal because you're electron poor, right? So these are going to be non-metal. And if you're going to be on the left side of the stairways, you're going to be metal,
Oh,
right?
that's true. Because noble gases are down there,
Yep,
like
exactly, right?
carbon and
Exactly.
nitrate. Okay, yeah. That's right.
Exactly. Again, when you think about the non-metal and metal, right? Non-metal is going to have gases, right? Like oxygen, chlorine, fluorine, bromine. We
Yeah.
cannot really comprehend them, right? They are going to be electron poor. They are not going to conduct electricity. But on the other side, if you look at the metal, they are going to be the opposite. They are going to be solid. You can actually grasp them, right? They will
hmm
conduct electricity and they will be electron rich, etc., etc. Okay?
Yeah.
Very good. And so now, again, let's think about now carbon. I'm just going to give you our first example. Let's bring our carbon here and oxygen. Okay. And let's say we have two of them. And so how we're going to name this compound. Okay. Maybe you already know what it is. Do you know what this is, by the way?
CO2.
CO2. What do we call it?
Carbon dioxide.
Okay, you already know, pretty good. But so why do you call them carbon dioxide, right? So let's actually take a look at here. So whenever we have non-metal to non-metal, right? The first thing here is the first element here is not going to change its name. And if you look at it, it's actually carbon right here, right? So we're going to actually put the carbon as carbon. All right. And then for the second one, now it's going to change its name because it becomes an anion. And for the second one, for the non-metal, for these guys, for nitrogen, oxygen, and fluorine, we're going to actually, what we're going to do is we're going to do a very simple thing. We're going to actually drop the last 3 or 4 letters at the end, and then we're going to add I, D, E, right? Okay, so if I can give you an example, for instance, right, oxygen or fluorine, right? So it was fluorine before it was reacting with the whatever the element is, right? But now, whenever it reacts, it becomes, we're going to drop the letter at the end, it becomes fluoride. Make sense?
Yeah.
Okay, same thing, right? If it's, for instance, oxygen, let's give an example for the oxygen. Oxygen. And now, again, we are going to drop the 4 letter at the end, and we are going to add I, right? Oxide. Okay, so again, if it's a nitrogen here, it's going to be nitride. If it's a phosphorus, it's going to become phosphide, sulfur, sulfide, etc., etc. All right. So now, if I come back here, then this again, now I cannot just call this carbon, oxygen, right? Now, because they reacted, they form a new compound, and it's going to have a new name, and so it will become carbon oxide. But you said actually dioxide, right? Because the reason here is because we have 2 of them. And whenever you have 2 of them, then we are going to actually, again, we are not going to call 2 oxide, but instead we are going to use the Latin prefixes. And if we can write it down, the Latin prefixes, if you have 1, right, it will be what? Mono, right?
Okay.
If you have 2, it will become
Something.
di, right? Very good. And oops, my bad. And then if you have 3,
Tri.
very good. And if you have 4,
Mm,
tetra, and
okay.
5, penta. I think this will be enough for now for us. Again, you need to actually memorize this 4, but it's not so bad, right? So now we have to add this here. And again, since you have 2 of them, you have to actually put the di here. So it will become carbon dioxide. Okay?
Yeah.
Very good. So let's do a one more example here to actually, there's actually a couple things that I want to emphasize more. So let's take a look at this example now. CO. Okay. And so if you look at this example, again, based on what we learned so far, right? How would you name this? The first one is carbon. Very
Carbon
good.
monoxide.
Okay. Okay, carbon monoxide, right? Very good. So you said that carbon monoxide. And what did you say? Monoxide, because for the second one, even if you have 1 of them, you still have to say how many, right? We have only 1 of them. And so 1 means in the Latin prefix mono. So we have to say carbon monoxide. Let's just put that in here as green color. So it will become carbon mono. And since you have 2 of them, 2O, I'll just drop the 1 of them and it will become carbon monoxide. Okay, very good. But what about if you have, let's do one more example to see if we can actually dive into a little bit more. So again, for the first one, as you can see, if you have only 1 of them, you don't say monocarbon dioxide, right? For the first one, if you have only 1 of them, you just say carbon. But if you have more than 1, then you actually also name that, like you have to indicate how many elements we have. Let me give you an example on that. So let's take a look at this one, for instance. Let's take a look at this guy here, N2O 4, for instance, right? Okay, so now, again, same thing, right? First, you need to actually identify whether it's a non-metal to non-metal, and then nitrogen is non-metal, and oxygen is non-metal too. So the first one is N. What was the N again? Again, the periodic table is a little up there, but you can hopefully have your periodic table in next to you. So it's nitrogen, right? Okay.
Nitrogen.
So should we say just nitrogen, or should we say
Dinitrogen.
dinitrogen, right? Very good. So we should be actually saying di, right? To indicate you have 2 of them, and then you're gonna say nitrogen. And then for the second one, how many,
Tetra.
right? Tetra, very good. Tetra. And then it's gonna be
Oxide.
oxide, very good.
Interesting. You don't take away the A because
Which one?
you wouldn't take away the A from Tetra and replace it with the O.
No, I think it should be fine. Dinitrogen tetroxide. Yep, because otherwise, yeah. I mean, for this one again, we have 2O. We just
Mhm.
swapped one of them, but you
Yeah.
got the idea, right? So you
Yeah.
just have to actually tell us how many elements that you have for both of them. Okay.
Okay.
And now, actually, I think everybody is understanding. Does anyone has any other questions at all?
No, I
No.
understand.
Okay. All right. So now I'm going to give you the whole class one more example to go over, and then we can actually move on to our next topic. So it's going to be, let's say, P2O5. So I'm going to actually let you guys do this example by yourselves. Okay. P2O5. And I'm going to give you a little time to go over.
So diphosphorate
Okay, so the P is again,
phosphorus.
yep, the phosphorus, right? You can look at your periodic table again. Okay, so the first one isn't going to change. Okay, right? So it will be phosphorus. Very good. Phosphorus, right?
Yep.
And because you have 2 of them, you have to actually put the di in front. Very good. And then you have oxygen, and but oxygen, we don't call it oxygen anymore, right? What do we call it?
Pentaoxide.
Right? Pentaoxide. Very good. Because you have 5 of them, so I still have to add the penta before the oxygen, and then I have to add oxide. So it's going to be pentaoxide. All right?
Mhm.
All right. Any questions, everybody? Are we
No.
good? Are we
Yeah.
good? Everybody's good?
Yep.
Okay. Okay. And now I will actually move on to our next topic, and then we can actually take from there. So now we've seen non-metal to non-metal, but what happens if you have metal to non-metal, right? So if I can give you, let's just write it down here, metal to non-metal. Okay. So again, just the simple example that we've seen in our slides, right? We talk about the household chemicals, like the salt, right? The simple salt is a non-metal to non-metal chemicals, right? If you think
Mhm.
about it, sodium, right, and chlorine. And again, if you look at the periodic table again, sodium is right here, as you can see, right? Okay, and it's actually metal, and the chlorine is here. It's non-metal, right? So it's going to be the same and similar, rules. So how would you name this based on what we learned so far?
Like based on what I learned
Mhm.
above or based on how it should
Yep. Based on what you learned so far
be?
above.
It would be sodium chloride
Okay, very good, right? Again, for the
or
metal,
sodium monochloride.
okay, very good, right? So for the metal and non-metal, based on
Mhm.
what you learned so far, you will be tempted to say sodium, right?
Yep.
And then you will be adding, since we learned to add mono, you will be adding the mono, right? But here again, because we are in the metal to non-metal, territory, right? we don't say how many for the second one or the first one. Okay, that's the key. So you're just gonna say sodium chloride. Okay.
Oh, you don't. Okay.
Yep. You don't say how many for the second one, right? Let me give you another example, for instance, so that we can actually, learn better. Like this guy here. Okay. So now you have two chlorine. So what should we say? Should we say dichloride or
I guess it's just chloride.
it's just chloride, right? Again, here, if it's metal to non-metal, again, you need to actually identify whether it's metal to non-metal, right? Because if you can identify that, then you're gonna have a problem. Make sense?
Mhm.
Right? So we know that magnesium is metal, right? Because it's actually on the left side of the stairways. So therefore, it will be actually magnesium, right? Again, the first one doesn't change anyway, right? So it's gonna be magnesium. And for the second one now, this is metal to non-metal. And again, because of that, we don't really say how many for the second one, right? We're just gonna say chloride. Make sense?
Yeah.
And again, I'm gonna actually explain that in a second why we do that. Because when it comes to naming, right, everyone, we are not gonna actually use a redundant information, right? So telling me that you have two chloride is gonna be redundant, and that's why we don't do that, okay? So again, to wrap it up, kind of, what we learned so far, if it's non-metal to non-metal, and by the way, I forgot to tell you that if you have a non-metal to non-metal, what kind of bond do you have, do you think, in this, compound, carbon to oxygen? It's covalent
Was
or
it?
ionic? We learned this in the previous, lessons, if you can remember.
I
No.
think the non-metals is
When they share electron, right? If you have a
okay.
non-metal to non-metal, both of them are electron poor. If you have both of them are electron poor, right? Then do you think you're gonna, give away electrons or you're gonna share electrons, right?
Yeah.
If you are, so you're
So
gonna be
it's
sharing,
covalent.
right? So it's gonna be covalent. Very good, right?
Hmm.
So it's gonna be covalent, and so for metal to non-metal, one of them is going to be electron rich. Now we have metal, which is electron rich, and non-metal, which is electron poor. Now they can actually exchange electrons, right? Because we have a poor and rich at the same time, right? So therefore, this is going to be ionic bond, okay?
Yep.
All right, very good. So again, to wrap up this session, so if you have a covalent bond, right, we have to actually name the second, elements. Even if you have only one or two, you have to tell me how many. But for the first one, if you have only one, you don't have to say how many. But if you have more than one, you have to tell me how many, right? So in other words, we are using these Latin prefixes in the covalent bond, right? Everybody? So for the non-metal to metal, if it's an ionic bond, then we don't really use the Latin prefixes. Okay? All right. Any questions so far? Everybody?
Oh,
Okay.
actually, there is a question.
Sure.
Because you've been saying a lot that we don't have to name the number in the second term.
Hmm.
But like, because you keep saying the second term, does that mean for the first term, I have to mention how many numbers?
Oh, for which one? Metal to non-metal or?
Yeah, for metal and non-metal.
Yeah. So for metal to non-metal, that's a good question. Again, it's the same rule, right? You don't have to say anything for the first one. We just,
Okay.
for both of the metal to non-metal and non-metal to non-metal, for the first element, right, we don't really say how many, right? Sorry, for the non-metal, we have to say it, but for the
Mhm.
metal, we don't have to say it, right? Again, we
Okay.
just learned here, if you have, for instance, two phosphorus, we just say di, right?
Yep.
If you have like two nitrogen, we say di. But if you have only one carbon, you don't say monocarbon, you just say carbon. Okay?
Okay.
But
Good.
for the metal, that I think that was your question. We don't really say how many. Even if you have like this guy here, I think that's going to be an answer to your question, right? N2O, right? How would
Mhm.
you name this, right? Like, are we going to say disodium?
No.
No, right? Very good. So it's going to be just sodium again. For non-metal to metal. We don't really care for the first one. There's going to be always, we're not going to use any, Latin prefixes. So it's going to be sodium. And the second one is going to be what? Oxygen.
Oxygen.
Oxygen
Yeah.
is going to become what?
Just oxygen.
Oxygen, but it's going to become oxide,
Oh,
right?
oxide.
Yeah,
Oxide.
remember? Yep, oxide. Okay, I think this was your question. Okay.
Yeah, that was. Thank
All
you.
right, all right. So so that's what we learn. And again, in the following classes, we are gonna actually dive together more into why in the metal to non-metal we are not actually using the Latin prefixes. Okay, I'm gonna actually explain those, and then we are gonna actually also learn about the polyatomic ions, right? And because these are just monoatomic ions, there's gonna be some polyatomic ions as well, and then that will be actually the end of this chapter. Okay, everyone? So if anyone has any questions. All right. So I'm gonna actually end this lecture and class then, and then I will see you next time. And again, before you leave, make sure to take your exit polls and make sure to answer those questions so that I can see whether you actually understand the concept or not. All right, everyone? Thank you so much, and I will see you next time. Bye.
Bye.